Ever pondered how the journey of space exploration commenced? Let's take a leap back in time. It all began centuries ago, when our ancestors started observing the night sky. They were the first astronomers, using simple tools to study the celestial bodies and their movements. However, these early observations were just the beginning of a long journey. Fast forward to the mid-20th century, a period marked by the throes of World War II. This global conflict, despite its many horrors, played an instrumental role in paving the way for space exploration. During these tumultuous times, Nazi Germany developed ballistic missiles, the most notable of which was the V-2 rocket. This rocket, the world's first long-range guided ballistic missile, was not just a weapon of destruction, but also a technological marvel that would serve as the foundation for future space launch vehicles. Between the years of 1942 and 1945, over 3,000 test launches of the V-2 rocket were conducted. These tests were primarily for military purposes, but they also demonstrated the feasibility of reaching the edge of space. The V-2 rocket became the blueprint for post-war rocket development, opening new possibilities for human exploration beyond our planet. The end of World War II didn't mean the end of rocket development. Quite the contrary, the United States and the Soviet Union, having captured German rocket technology and scientists, continued the work started by the Germans. This led to the development of intercontinental ballistic missiles, or ICBMs, laying the groundwork for future space exploration efforts. So the stage was set. The foundation had been laid. The next steps would take us from the realm of possibility to the reality of humans venturing beyond the confines of our home planet. This was the dawn of space exploration. Thus, World War II set the stage for space exploration with the advent of the V-2 rocket. The V-2 rocket launches between 1942 and 1945 were pivotal in demonstrating the feasibility of reaching space. The V-2, or Vergeltungswaffe 2, was the world's first long-range guided ballistic missile, developed by Nazi Germany during the height of World War II. Over 3,000 test launches were conducted, pushing the boundaries of technology at the time. Though primarily intended for military use, the V-2 rockets were more than a weapon. They were a technological marvel, a symbol of human ingenuity and determination. Even in the darkest of times, these rockets were capable of reaching the edge of space, a feat that had never been accomplished before. This was the first real hint that human-made objects could venture beyond the confines of our planet, a crucial stepping stone on the path to space exploration. But the story doesn't end there. Following the war, both the United States and the Soviet Union, the world's emerging superpowers, seized upon German rocket technology and scientists. The two nations were keen to harness the potential of these powerful machines, not just for military purposes, but for scientific exploration as well. The United States initiated Operation Paperclip, recruiting German scientists, engineers, and technicians, notably Wernher von Braun, the chief architect of the V-2 rocket. Similarly, the Soviet Union launched Operation Oswiakim, forcibly transporting thousands of German specialists to the USSR. This post-war scramble for knowledge and expertise led to the development of intercontinental ballistic missiles, or ICBMs. But more importantly, it laid the groundwork for future space exploration efforts. The V-2 rocket's legacy extends far beyond its wartime origins, influencing the design of many later rockets, including those that would eventually carry humans into space. This period marked a significant leap towards space exploration, laying the groundwork for future endeavors. The tale of the V-2 rocket is a testament to humanity's relentless pursuit of knowledge and progress, even amidst global conflict. It set the stage for the space race, an era of unbridled innovation, competition, and discovery that forever changed our understanding of the universe. The International Geophysical Year of 1957 served as a turning point in space exploration. This was a time when scientists around the globe collaborated in a series of coordinated observations of various geophysical phenomena. It was during this period that both the United States and the Soviet Union announced their audacious plans to launch artificial satellites into space. It was an era of technological revolution, and the International Geophysical Year served as a platform to showcase the remarkable advancements made in the field of rocket science. The United States, under the banner of the newly formed NASA, announced its intention to send the Vanguard satellite into space. The Soviet Union, not to be outdone, declared they too would launch their own artificial satellite, the Sputnik. The stage was set for a showdown that would redefine the limits of human achievement. These plans weren't just about demonstrating technological prowess, they were about asserting dominance in a new frontier: space. The International Geophysical Year became the backdrop for the first act of the space race. As the United States and Soviet Union prepared for their respective launches, the world watched with bated breath. It was clear that whoever succeeded in launching the first artificial satellite would gain a significant advantage in this new arena of competition. This was more than a scientific endeavor, it was a geopolitical chess match played out on a cosmic scale. The International Geophysical Year was a pivotal moment in history. It was a time when the ambitions and dreams of nations were not confined to the Earth, but reached out into the vast expanse of space. It was a time that marked the beginning of a new era, an era in which humanity would venture beyond the confines of our planet and step into the infinite. The ambitious plans announced during the International Geophysical Year set the stage for the monumental achievements that would follow in the decades to come. The launch of the artificial satellites marked the dawn of the space age, a period of exploration and discovery that continues to this day. This period served as a catalyst, sparking a competitive spirit in space exploration. The International Geophysical Year was the starting gun in the race to space, a race that continues to push the boundaries of human knowledge and capability. October 4th, 1957 marked a historic day in space exploration with the launch of Sputnik 1. The Soviet Union had taken a significant leap forward in the field of space exploration, unveiling a new frontier of human achievement. Sputnik 1 was the first artificial satellite to orbit the Earth, a spherical object weighing about 183 pounds with 4 trailing antennas that broadcast radio signals back to Earth. Its successful launch was not just a technological triumph but a political one too. The Soviet Union had demonstrated its superior capabilities in rocket technology, effectively ushering in a new era of political, military, technological, and scientific developments. This event didn't just echo in the halls of Soviet leadership, but it reverberated across the globe, reaching the United States, the Soviet Union's Cold War adversary. The American administration, led by President Dwight D. Eisenhower, was caught off guard. They had underestimated the technological prowess of the Soviet Union, and the launch of Sputnik 1 was a wake-up call. This surprising turn of events ignited what is now known as the space race. This was not just a race for supremacy in space exploration, but also a symbolic contest of ideologies between the two superpowers. The space race was a reflection of the competition between the democratic capitalism of the United States and the communist socialism of the Soviet Union, each vying for global influence and dominance. The launch of Sputnik 1 and the subsequent space race that it ignited led to a flurry of activities in the field of space exploration. It spurred the United States to establish NASA, initiate the Mercury and Apollo programs, and eventually land the first humans on the moon. Looking back, it's evident that Sputnik 1 was more than just a satellite. It was a catalyst that set the stage for the exploration of the final frontier. It was the spark that ignited the flame of human curiosity and ambition, leading us to explore beyond our own planet and reach for the stars. The launch of Sputnik 1, the first artificial satellite, heralded the beginning of the space age. Post the Sputnik era, the timeline of space exploration is adorned with significant milestones. As we traverse this timeline, we encounter the Mercury and Vostok programs, a testament to the spirit of competition between the United States and the Soviet Union. The Mercury program, initiated by the United States, marked the first human spaceflight initiative of the country. Comprising a total of 6 manned flights between 1961 and 1963, it aimed to put a man in orbit around the Earth, and it did. The first American astronaut to orbit our planet was John Glenn, aboard the Friendship 7 in February 1962. Parallelly, the Soviet Union was making strides of its own with the Vostok program. The most notable achievement of this program was sending the first human, Yuri Gagarin, into space in April 1961, a feat that predates the Mercury program's success. The Vostok program also saw the first woman, Valentina Tereshkova, orbiting the Earth in 1963. Then the world witnessed the extraordinary Apollo program. This ambitious project saw 12 astronauts walk on the lunar surface between 1969 and 1972, with Neil Armstrong being the first, uttering the immemorial words, "That's one small step for man, one giant leap for mankind." Moving forward, the space shuttle era brought about a new phase of space exploration. It allowed for the regular transportation of astronauts and supplies to and from space, making space more accessible than ever before. The establishment of the International Space Station, a joint venture involving 5 space agencies, marked a significant advancement in human spaceflight. It serves as a home where astronauts live and work, conducting a myriad of scientific research. We also saw the dawn of robotic exploration, with Spirit rovers and probes venturing to Mars and beyond, providing valuable data about our universe. And finally, we've entered the era of commercial spaceflight, with private companies taking the reins and pushing the boundaries of what's possible. These milestones represent the relentless human pursuit of exploring the final frontier: space.